Okay, so let's go through the review here. So the first four questions are free response problems, and so they're going to be worth 10 points each. Okay, so write a brief description of the distribution of scores on this exam. So you want to talk in context. These are scores on the exam. You want to hit the four things there: shape, center, outlier, and variability. So first thing you might say is, you see the outliers on the left here. It has a long tail, so the scores are skewed left. Okay, as far as center, you can count it out. There's 25 terms. So if you go 1, 2, 3, 4, 5, 6, counting from the left, 7, 8, 9, 10, 11, 12, 13. That's the 13th term. Looks to be 89, or you can just read it. I think it's right there. It actually tells you. So you can say that the median score is 89. Good idea to just get used to answering these questions with sentences. Usually be better to include the context more when you do that. Next thing would be the outliers. I'm not sure really any of these values might be outliers. They're possible outliers. And it's okay to say that. There are possible outliers. At outlying scores maybe, talking context, at 65, 70, maybe 72, possibly, I don't know. And lastly, variability. So the scores of Mr. Donahue's statistics students vary between 65 and 96. Perfect. That's a great description. Again, with quantitative data, you want to describe those four things: shape, center, outliers, and variability. Get that in your head. You got to know those. Okay. If you estimate the mean, it's about the same as the median, higher than the median, or lower than the median. Well, it's skewed left. So whenever the data is skewed left, which certainly is the case here, that mean gets pulled with the skew. The mean is going to get, the median might be close to the peak there, very likely. But the mean is going to get pulled to the left with the skew. These outlying values have these values out here to the left have a huge effect, so the mean gets smaller. And it's okay to say it like that. The mean will be smaller than the median because it's okay to say it's skewed left. That's a pretty good reason. Mr. Donahue decides that because the test was quite difficult, he will add 5 points to score rating and outlier score the next teacher. Community test scores qualify for this bonus, so we're going to use our formula: Q3 plus 1.5 IQRs, Q1 minus 1.5 IQRs. It says that Q1 and Q3 are those, so the IQR would be a distance of 9 is our IQR. I don't think I really even have to test it on the right. There's no outliers on the right. They're all clumped up right there, so there's really no chance for an outlier there. I am going to test it on the left, though. I'm going to plug into the lower fence formula, Q1 minus 1.5 times the IQR. Again, the upper bound would just be Q3 plus 1.5 IQR. So this would be Q1 is 84 minus 1.5 times 9. 70.5. So there are two values that are outliers according to the formula. There are two low scores. There are two low scores. This is done in statistics class. That are outliers. 65 and 70. Beautiful job on the first question. Okay, so second question. Each apple in a sample of 20 apples was measured. Here's all the 20 different measurements. Use your calculator to find the mean and standard deviation. So you might want to get your calculator out, hit the home key, go to list and spreadsheets, title the list apple, type in all those data pieces. I've already done that. Maybe add a calculator page. So I like to go down to the bottom there, to the bottom left. Don't go to scratch pad, so I can talk through that page. And now I'm on page 1.2. And I'm going to hit menu 6, which is statistics. 1-1, the stat calculation will the stat. Press OK for one list. Name the list. I like to click inside of there and just choose the name, which is Apple, rather than typing it, and just press enter. It does one variable stat. Mouse up one click. There it is. So X bar, the mean is 89.12. The one you need there, calculate the mean and standard deviation. So the mean is 89.12. And the standard deviation of the sample is 8.345. Is the standard deviation. So 8.345. Interpret this standard deviation. So the first one just wants, oh wait, are these statistics or parameters? So X bar is the mean of the sample. S stands for the sample standard deviation. And so this is a sample, right? This is a sample. So that's why I chose the sample standard deviation and chose X bar, which would be sample mean. So these are definitely S starts statistics, it starts with S sample. If it was from the population, it would be a parameter. So these are statistics. I should probably put that in a sentence, but right there. These values, these these apple weights are statistics. Interpret the standard deviation. So standard deviation is the typical deviation from the mean. So in this case, the apples, the weight of the apples varies typically by about 8.345 from the mean. So you'd say that. And if you want to talk about, that's the concept, but apply it to this situation. The weight of the apple varies by about 8.345 grams away from the typical. Okay, suppose 3 more apples were added to the data with equal weight to the mean. So the mean is 89.12. So we found 3 more apples that's 89.12. We don't need to type it back out there. We could have 3 more values, recalculate. But would it have an impact? So think about it, deviation from the mean. So those 3 values have no deviation from the mean. So I'm adding 3 values that have a deviation of 0 from the mean. 0 plus 0 plus 0. Is that going to bring the mean, the standard deviation down? If more values are closer to the mean, or is it going to bring it up if values are further away from the mean? I think more values are closer, so I would say the standard deviation of apple weights is going to decrease. Standard deviation, probably shouldn't preview that word, but apple, I just in a hurry, that's how it works. Weights is going to decrease. It's going to decrease. Because all the values you add have a deviation from 0. All 3 values you add have a deviation from mean, which is 0. There's no deviation. It's going to make a deviation. It was later until you would like that. It was later discovered that the weighing scale was not calibrated and each apple was underweight by 5 grams. So if you add 5 grams to the weight of, so everything gets 5 weighted to it, added to it. Would the value of the mean, the standard deviation, change? Or what would they be? So the old mean was 89.12. So we're adding 5 to that, so that's going to be 94.12 grams. Is the deviation. So all of them are going about the same amount. So the spread is not going to really change. So the spread is 8.345 would be the sample standard deviation of this mean. These are the lengths of the 25 most popular movies. I remember Titanic being a very long movie. That might be one of these, I'm not sure. It's voted on by visitors to a website devoted to movies. Make a stem plot. So this one's going to be a little bit difficult. It's not a 2-digit thing. The leaves have to be 1 digit. So in this case, that means that some of the stems will be 2 digits. The smallest number I see is 96. The biggest number I see is maybe 200. Looks like 200. Okay, so I need stems that go from 9 all the way to 20. So yeah, stems that go from 9 to 20. So 9, 10, 11, 12, 13. And so then you just start filling in the stems. I think there's a 96 there. There's 102 and a 106. 3 109s. 112, 115, 118, 119, 121, 124. 130, 133, 136, 142, 146, 152, 154, 161, 165, 175, this takes a while, 178, 195, 190. Okay. So we're not done. So we need to make a key. So in this case, the key, we pick out one of these. I don't know. I'm going to say 10, line 6 represents, so a mean, a movie, so means a movie length. We're talking about movies here. Of 96 up 106 minutes. The mean of this distribution is 136.28 and the median is 130. Okay, so the mean is bigger than the median. Explain why you could have predicted that the mean would be higher than the median by looking at the stem plot. So if you turn this thing 90 degrees, the shape of it would kind of look like this. The outliers may be some of these bigger numbers if there are outliers there. So it definitely seems skewed right. So if it's skewed right, again, the mean is going to get pulled with the skew here. The median is going to stay near the peak of that guy, so probably somewhere in there. And so the mean is going to be the mean, what is this, number of minutes, of movie minutes, is greater than the median. And we can't read already. Because the graph of the distribution of movie lengths is skewed right, because it's skewed right. Then talk in context, that's the idea. To make a dot plot, so we've got to figure out, let's see, the smallest term I see is a 2, I do see an 11, so I need from 2 to 11, so I might just go by ones. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Probably should have moved that a little differently, but okay, so and then I need to label, sorry, probably should have some room underneath here, so a label underneath, what does this represent? This seems to be word length. We're talking about the word length, so I probably should put that right underneath there, but I ran out of room. The word length is the axis there. Then you're just going to start put all the dots there. Looks like we have like 6 twos. 4 threes. We've got 6 fours. 2 fives. 1 6. You don't really need a frequency on the left here with the dot plot. You can just leave it like that. 2 8s. 1 10. And 1 11. Okay, so if you look at that dot plot, okay, so it's definitely, so we make a dot plot, so we made the dot plot. That's great. Describe the distribution of word length. So you want to hit all the big things. So we're going to say that this the distribution of word length is skewed right. So I'm just going to write skewed right, but I hope you heard that sentence. Skewed to the right is the shape. Center. We've got to find the center here. Looks like there are 25, so the 13th. These are from the right or left. They don't come from the right. It might be easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's say that one's in the middle. So 4 is the median word length. So 4 is the median word length. Let's do outliers now. So outliers, possible outliers. At 10 and 11 word lengths. Okay, and then variability, it looks like the variability is from 2 to 11. Again, that's the word length from 2 to 11. For word length. Okay, and close it. So this is a sample of birth weights of infants, of 160 infants. So that's important. So they want 40 below what value? So I guess the bottom 40. Remember, how much of the data is in this top part from Q3 to the max? That's 25% of the data. Well, 25% of 150, 1/4 of 150, which is 40 students are right there to the right of that. There are 40 students in this 25%. There are 40 students in this 25%. And so there are definitely 40 students in that 25% as well. So below, what is that value? I don't know. A little more than 100, less than 110. It's got to be. Mr. Cottrell asked the 26 seniors in the statistics class how many AP courses they've taken during high school. Here's the dot plot. So some took as many, so a lot of folks took 3, some people took 6. Some St. Mary's girls take them in 1 year. What is the interquartile range for the number of AP courses? Okay, so the interquartile range. Okay, so we've got to figure this out. So you could, there's 26, so the 13th and 14th term is the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. These are the 2 middle terms. So 3 is the median number of AP courses. And that's right in the middle right there. We cut the data right in half right there. So if you, so that's at the 13th and 14th. So there's 13 below that, and there's 13 above that value right there, that line right there. So 13 below, so the half 13 is 6.5. So the seventh term is the Q1. So 1, 2, 3, 4, 5, 6, 7. So this is the seventh term, so that's my Q1. Going for the other side, 1, 2, 3, 4, 5, 6, 7. That's my Q3. And so what is the interquartile range? It's going to be 5 minus 3, which is 2. What is that stuff? Whenever people work at lag time internet secure services, suppose that a particularly successful year, the president of the company decided to double his own salary and not change anyone else's. So nice. Assuming the president makes more than anyone else, which of the following statements about the change in the measure that spread is true? So whatever the largest value was, there's a whole bunch of values here. Let's say he was making 100,000 to begin with. But now he ups it to 500,000 because he thinks he's worth it. And he didn't want to give anyone else a raise, but that's the only number that changed. If that's the only number that changed, now it probably was an outlier before. It's probably for sure an outlier now. So how would that change the mean and standard deviation and the median and the interquartile range? So let's think about it. Is the mean pretty much affected? So the mean is going to get a lot bigger because it's very affected by outliers. The standard deviation is going to get a lot bigger. It's very affected by outliers. What's resistant to outliers? The median is very resistant measure of spread, so that's going to stay the same, so to speak. It's not going to change, especially since that value is replaced. If it was just added 500,000, like another number there, it might change slightly, but not much. And I think actually the Q1 and Q3, it doesn't look like those would change at all. So I think IQR is a resistant measure. I guess I thought of that, but that one's going to be the same. It shouldn't change at all. I think the same. Yeah. The following statements about standard deviation is true. So, oh man, standard deviation. So standard deviation measures the typical distance data points are from the median. Oh no, that's not true. That's a silly one. It's from the median, right? Regardless of what units are data, standard deviation has no unit. Actually, that's not true. It has a unit, whatever, if you're measuring in centimeters, that's the unit. Variance is that unit. Variance is standard deviation squared. Standard deviation is always non-negative. I think that's true. Non-negative means positive or zero, and it could be zero. So I think that's true, but I just want to read them all. The data set is measured in hours. Standard deviation was measured in hours. That in hours squared. Oh, I thought we had it. And that would be variance to the hours squared, but that's not it. Standard deviation is resistant to outliers. No way. Like we just talked about it. Standard deviation is not resistant to measure. Median and IQR are pretty resistant. It's got to be true. All of the following distributions have a mean of 10. Oh, that's nice. What is the largest standard deviation? So which one would have, so this one would be the smallest standard deviation. It has a standard deviation of 0. None of those values deviate from the mean at all. So we want to find data values that are a lot spread out from each other. So not very many values are on the mean. These are somewhat spread out like the other 15s, but the 10s there are right on the mean. So that's not going to be that spread out because 3 of them have a standard deviation of 0, just with those 3. These are more evenly spread out, which, well, would be something there, but it seems like the most spread out would be B. Again, we could calculate that if you want to type in a list. Do one variable stats on each of those lists. It'll calculate the actual standard deviation. So you could certainly do that, but I don't think it's necessary on that problem, but you could. Time it takes people to finish a certain kind of puzzle is strongly skewed to the right. I like to draw and think about that. Skewed to the right, which is one thing that's true about the mean and median. The mean and median will be exactly equal. That's for symmetric, not for skewed. Mean and median will be approximately equal, but that's symmetric. Well, actually, so that would not be true for, that would be perfectly symmetric. That would be true. This would be true for most symmetric. The mean will be less than the median. So I think that mean is going to get pulled with the skew. It's going to the right. So I don't think that works. The mean would be greater than mean. That's looking good. Which measure center is greater depends on how strong these two. I don't think so. Okay, which of the following graphs can be used to summarize the data in a two-way table? So a two-way table has two categorical variables there. So when you have two categorical variables, you're not using categorical, you're not using dot plots, you're not using box plots, or stem plots, or histogram. You're using a bar graph, right? In this case, a side-by-side bar graph or a segmented bar graph are both okay for that kind of data. And of the choices, that would be the thing. So this is for categorical. All the rest of these are quantitative. Right, those are quantitative steps. That's a really good one. We're getting there. A review of voter registration records in a small town using the following table: the number of males and females registered as Democrat, Republican, or some other affiliation. What proportion of registered Democrats are males? So, of registered Democrats. So I'm only looking at the Democrats. I'm looking at these folks. There are 900 of those folks. So what proportion are male? 300 out of 900. I think I know that one without using my calculator. But you could use a calculator. Thank you for that. Okay, Mr. Schwarzenegger, select a random sample of 100 students in grades 10 through 12. Ask their year in school and whether they're involved in sports, intramural sports, or no sports. So the results are summarized in the segmented bar graph below. So that's the three different types of sports. Nice graph. Done by percentage. Some of you in the example in class, the A-Lab didn't do percentages. Always good because the class size may be different. Always compare percentages. Which of following statements true? More seniors are involved in interclassic sports than sophomores. So are they saying a greater percentage? Random select of 100 students in grades 10 through 12. So we don't really know how many sophomores and how many seniors or juniors there are in each group. So more seniors, I don't think we know. We don't know how many seniors there are. There's no association between year and school. So if there's no association, then these would all be the same kind of breakdown here. Those are not all the same. There are more seniors in the sample than juniors. Again, we don't know anything about the numbers. We might be able to talk about percentages, but not numbers. We don't know how many each one were. Juniors have the highest percentage participation in juniors and intramurals. Intramurals is that guy. Yes, the checked one does seem large for juniors. That seems correct. Less than half the seniors are involved in either interscholastic or intramural. Actually, interscholastic more than half, so I think that works. A survey typically records many variables of interest to the researcher involved. Below are some variables from a survey conducted by the U.S. Postal Service. Which of the variables is categorical? So let's go number of rooms, that's quantitative. Age of respondent, quantitative. Total household income, quantitative. Number of people, country of residence, like USA. Yeah, that's not even a number. Finally, the pie chart is like describe your student's favorite school subject for 300 high school students. How many students reported math as their favorite subject? So I might need to get a calculator for this one. I'll go back down here. So I'm going to add up what they are. 74, so there's 26% like total. 26%. How many students? It didn't say the percentage, so that would be a very tempting answer there, that 26, but that's not percent. How many students? Well, out of 300, 26% are math grades, right? So you're going to go, okay, 300 times 0.26 is 78. And that kind of makes sense. Like you're looking at that, that's a little less than a third would be 100. So yeah, you're in the ballpark. One of these for sure, if you're just going to get them. Great.